Here is a quiz that I give to my Chem 30s, but I usually just do it for practice and not for marks, so I thought it would be a good one to go over. So this is as soon as we're done all naming, a chance to see that we know how to name. So your first one saying what is an unsaturated hydrocarbon. So for some compound to be unsaturated, you must have a double bond or a triple bond. So this first answer, which says contains only single, that's not true. The second one, a hydrocarbon which contains at least one double or triple carbon-carbon bond, that is going to be our answer. But let's just double check the other ones. So C, an alkane. Alkane means single bonds. And D, a hydrocarbon which only contains one carbon atom per molecule. That's not part of our definition, so we can rule that one out. So here your answer definitely was B. The next one, naming the correct name for this compound. So I believe this is just the formatting. It looks a little bit weird here. I think this was just moved over and this is just moved over. So you definitely have butane as your longest chain because it's all single bonds, and we would have lines in here. So it's going to be butane as your longest chain. So we can take off these two. And then on carbon, once you number it, and it doesn't matter which direction you start numbering, it's going to have two methyl groups, one on carbon 2, one on carbon 3. And because there's two of them, you need to say di. So your answer here is A. It's not B because B is not telling you where to find those carbons. Number 3, which of the following is 2-methyl propane 2-ol? So this is showing you have a alcohol group on carbon 2. So looking at this first 2, we can rule out because it's looking like our OH group is going to be on our first carbon. Letter C, it almost looks like it could be the one because we do have an OH group on what could be carbon 2, but propane means 3 carbons in your longest chain, and this one is showing 4. So this last one, you have a propane. So we have 3 carbons on our longest chain. You have an OH group on carbon 2 and a methyl group on carbon 2. So this has to be D. For number 4, name the following ester. Here, if we were to take a look and draw it out, this is where our ester functional group is. So carbon double bonded to an oxygen, single bonded to an oxygen. And this chain over here is connected to that. And this part over here is connected to the carbon that's double bonded to the oxygen. So your CH2 and CH3. So this would be because you have 2 carbons connected to the oxygen, which we named first. That would be an ethyl group, so we can rule out these 2. And then the part that came from the carboxylic acid was attached to that double bonded carbon, which has 1, 2, 3. So if there's 3, it would be propanoate. So this is ethyl propanoate. Number 5, study the following structure and determine the functional groups present. So here, taking a look, we should identify this as a carboxylic acid and this as an alcohol. So let's go through this. Hydroxyl and an ester. There's no ester present. A hydroxyl, yep, because of the OH. Carboxyl, yep, because of the carboxyl group on the end. So this is going to be B. Letter C, carboxyl and a halogen. To be a halogen, you must see a halogen. So from group 17 of the periodic table. And D, an alcohol, which we do see, which is also an OH group. And a polymer. We haven't covered polymers yet in Chemistry 30. That's one of the very last things we do. But this is not going to be a polymer because polymers are longer and have a repeating link. So we're going to rule this one out because we don't know that yet. And the best answer so far is B. Once you learn polymer, you'll know that that's not a choice. And the only answer is B. Number 6, the boiling points from smallest to largest of an aliphatic family. And here you might also see the term homogeneous. And that just means you're part of the same. You're just increasing in carbons. So from smallest to largest, your boiling point increases, right? So it's not decrease, won't stay constant, and this last one's not True. So the bigger the molecule, the more energy it will need to break it apart, which means increasing your boiling point. Moving on to number 7, which of the following rules identifies the condensed structure? I believe I did this in another one, but we can still try it. So we have C6H12. That means you must have 6 carbons, which the first one would. And now we have to count our hydrogens. So when we're taking a look, we have 3 here. There'd be 1 carbon here, 2 here, 2 here, 2 here, 2 here. So counting that, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is definitely going to work, and the name of this is methyl cyclopentane. So checking the other ones just to rule them out. For B, again, we know we have carbons. We have 6 of them because it's a hexagon. And then implying your hydrogens, so where the double bond is, you would only have 1 hydrogen. So I'm just drawing in hydrogen, but now I'm going to switch to numbers. Here you'll have 2, here you'll have 2, 2, and 2. So that's 2, 4, 6, 8, and then up here makes 10. So not going to be this. C, 1, 2, 3, 4, 5, 6 carbons. Count those hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Not this one. And then your last one, you have 6 carbons, and then 3, 4, 5, 6, 7, 8, 9, 10. So not that one. So all of these 3 would be isomers of C6H10. So they would be isomers of each other, but only A fits the C6H12. Number 8, a mixture of liquid methanol and liquid ethanol can be separated by blank, and the physical characteristics of these compounds that allow the separation is blank. So this is showing that we know fractal distillation. So it wouldn't be precipitation because that would mean a solid is forming, and that is not how we would separate methanol and ethanol. So fractional distillation we have talked about, and that's when you have that big machine that you're just boiling hydrocarbons. So it's getting hot, and the smaller hydrocarbons will float to the top and come out first as a gas. So that would be the smaller molecules, and the larger ones stay at the bottom. So fractional distillation will separate those molecules, and it is by boiling point because you are adding in that heat. Numerical response number 1 here about methyl cyclopentane. So when you are numbering it, the first thing we want to do is figure out the structure. So it's not going to be 1 because that's a benzene ring in there. It's most likely 2. Let's just double check with 3. It's not 3 because this is an ethyl group and there's 6 carbons in the ring, which would be hexane. So the first one here is 2. And then the next part, you have going to branched or unbranched. You have the CH3 on top, so that would be a branch. I said branch, but then wrote 5. So 4 is branched. Then it is all unsaturated because it is, what am I doing? There are no double or triple bonds, so they are saturated. So every carbon within the molecule is bonded to 4 other atoms. So that would be 6. And then lastly, it's an alkane because there's all single bonds. So alkene means you have double bonds. We don't see any. So this last part is 8. All right. So looking over this, I believe, maybe it's the second last question. I thought it was the last one. Another organic compound. Looking through, if you're looking for an alkene, we just need the ending of the names, the suffix, and the one that ends in ene is number 1. If you have an alcohol, you have an OH group present, so number 6 contains a triple bond. You want to end in YNE, so that would be 4. And then saying cyclic and saturated. So cyclic means you have cyclo in the mean. Saturated means you have to end in ANE. So that would be number 5. Right, so if you went to go pick number 1, could work for being cyclic because you do see cyclo, but because of the ENE, that means there's double bonds, which is not saturated. So 1, 6, 4, 5. Okay, so here is our last one. 2 properties that cyclopentanol and pentanoic acid have in common are that they have the same number of blank and they are both blank. So when I'm doing this question, it might help to draw it. If it helps you, draw it. If it doesn't, then don't. So if it's cyclo, which looks like this was just a spelling error, but cyclo, and it's pentanol, that means you have a 5-carbon ring, and on one of the carbons, which is implied to be carbon 1, you have an OH group. So just to answer the question here, that would mean you have 5 carbons, 1 oxygen, and then you have to figure out how many hydrogens you have. So 1 from the OH group, there would be 1 more hydrogen on this carbon here, so that's 2. 2 from here brings us to 4, 2 from here brings us to 6, 2 from here brings us to 8, and 2 from here brings us to 9. So 9 hydrogens. So let's look at pentanoic acid. Pentanoic acid is a carboxylic acid, so it has the C double bond O, double bond to OH, and if it's penta, that means it's 5 carbons in its main chain, and then we'll fill in the hydrogens. So carbon 1, no hydrogens, carbon 2 gets 2, carbon 3 gets 2, carbon 4 gets 2, carbon 5 gets 3. So when you are looking at this one, you can hopefully see right away that there are still 5 carbons, but here there's 2 oxygens. So we can rule out A and B. And then for hydrogens, just to go one more time, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10. But it wasn't asking you for hydrogens, that was just extra. So here it has to be C and D carbon atoms in their parent chain. We do have the same amount, right? 5 in each. And then to be aromatic, you have to see the benzene ring. If you do not see benzene, it's just aliphatic. So this would be C because we don't see the benzene ring, right? Benzene looks like that. We don't see it there, so it is not aromatic. So if this you found helpful, please make sure to like and subscribe. And if you have any ideas of a video to do, please just let me know and leave me a comment. Thank you for watching. I hope this helps.